So today we're doing annuities. So the other day we started looking at Finance Solver and using reducing balance loans. So when we were getting a loan and we were reducing it by a payment. So because it was a loan, the bank's not going to give you money for free. So the interest was getting charged and then you were trying to pay it off. With an annuity, it is now where you have an investment. So you are giving the bank your money. So you're investing it. So the bank is going to say, yep, and it will give you interest for giving it. So your investment will grow. Now with an annuity, what happens is, so you put in a certain amount of money to begin with and it makes interest. But you are going to take away money on a regular payment just to maybe do something. So say a lot of people might go, all right, I've saved up 10,000, I'm going to go on a trip to Europe, okay? So they'll put it in an annuity, in an investment. So it will start making money and then they will slowly take it out. So they might have said, oh, okay, I've budgeted for, $500 a week or whatever. So they're going to take that out weekly, but you can still make a little bit of money on the investment that you're sitting in there. So you hopefully can get a little bit more out of it. So that's an annuity. So you put your money in and you keep taking it out until it exhausts out. But you're going to gain a little bit more, aren't you? Because they're going to give you interest. All right, so we can still do them on Finance Solver. We just have to be really careful with how you put it, positive or negative. When you invest the money into the bank, so that'll be your PV, but because you're giving it to the bank, is it negative or positive? If you give it to the bank, is it going away from you? Yes, so it's negative. When you receive a payment back, is it a good day? You're getting some money in your hand, so it is a positive. So can you see it's the reverse? So we'll look at them in a minute. If you have to set up a recursion relation for an annuity, you can see it looks like, down here, and it looks similar to a reducing balance loan as well, because it's sort of the same thing, that it's gaining interest and you're taking away to exhaust it out. So you're taking away. So as a recurrence model, it will look similar, but into the Finance Solver, it will look different. So let's go and do this question up here. And it says, Johnny plans to travel overseas for 6 months. So that might be giving you, let's move that down a bit. That might be showing you an end value there. So he invests $12,000. So here's where I might start saying, all right, he's going to invest, so that's a negative PV, okay? The annuity will earn an interest rate of 6% per annum, so that is my I, and providing him with a monthly income of $2,000 and that per month. So that is a payment he's going to receive. So that's going to be a positive PMT in our Finance Solver. So it says to model this annuity, you can set up the recurrence relation where VN is the value of the annuity after end payments. So because this is a monthly formula, we need to work out this R value here, and we'll have to work it out as a month. So if we worked out how to work out that R value, this R value, I should have put it down here. So over here on the other side where it says 1 plus, R is going to equal 1 plus, the rate divided by PPY over 100. Okay, sorry, I think that missed out there. Okay, so we're going to do that up here. What would the PPY be if it's monthly? 12? Yeah, good. I think I heard someone say that. So it'll be 1 plus 12. Oh, no, what was the interest rate? Sorry. What was the interest rate? 6? Good. Sorry, rubbing that out. If it works. Come on. Yep, thank you. All right, 6. So 1 plus 6 over 12 over 100. So that will be the R. So if you do 6 over 12, that's half, isn't it? And so here, can you see that's where, well, I'll just write that. It equals 1.005, and that is where they've got this value here. Yeah? Now, the payment was minus 2 so we've got that there, and there we've set up a recurrence relation. So if they're asking me to do that, this is what I need to answer. This would be the answer for the recurrence relation. You have to have all of that. You've got to have VO listed. Oh yeah, sorry. Okay, so let's do this new little question. So Johnny's annuity can be modelled by the recurrence relation there, VO equals, which is good because that's what we got. Where VN is the value of the annuity after N payments have been received. It says use your calculator to determine recursively Johnny's, the value of his annuity after 3 payments. So I'll do that on the calculator to show you how to do it on that recursive. Okay, so now we're going to look at an amortization table, but now with annuities. So you've got to be careful. It's still the same thing. So you'll start off, if you have a look here, you have your initial starting. In the first month, that investment of $12,000 made $60 of interest. So even though he took out a payment of $2,035, his investment didn't drop by that much because he'd actually gained $60. So can you see that if you do that minus that, what it actually went down by, which is called principal reduction. So principal is the amount you've got at that moment, which it was $12,000 to begin with. And then reduction, how much is it dropping by? So can you see if you minus, he really is only reducing it, even though he's taking $2,035 out, he's only reducing it by $1,975 because he made interest. Does that make sense? Yes? So that's why it looks very similar to a loan because it is the same, will look the same, and you do the same, but it's an investment. It's just actually they're getting money and you're going to exhaust it out until you've zero, so you can't use this investment anymore. All right, so it's all done the same. So I'm going to show you it says properties of the annuity under there. So the interest earn, I want to do these with you. So I might do this one. See here, highlighting it. Interest earned is the interest rate per compounding period times the balance. So if we do that up here, I'm going to show you what we don't know what the interest rate is just looking at this table, do we? We can't see what the interest rate, the actual percentage rate is. We can see what it is. But if you look at that formula, it says interest equals the percentage rate per period times the balance before, it should be. Like, I think I like to say balance before, so you know that. So if I write that out, I can also write that as it would be the rate per annum divided by PPY over 100 times the balance before. Sorry, I'm just writing B4 for B4, sorry, because it's a bit hard to think. So, can you see, if I do, I'm going to do an example here. I'm going to use this one, this interest, and that balance before. So, can you see, I know the interest was 30.23, and it equaled, now the R, I don't know, but PPY, we knew this was a monthly thing, didn't we? We're just going to say yes. And over 100 times the balance before, which would be 6045.33. So if I was trying to find the interest rate, could I just do solve because I only have one thing missing? Yes. So I'll use that and I'm going to find R. So what is R for us is the per annum rate. So we'll do that, comma R, and I'll do that on calc. So when we do that, we get 6.002. So we know the percentage is R equals 6%. That's per annum. If you were trying to find the monthly rate will equal 6 divided by 12. So that's where we get 0.5%. Okay, so there's a way of finding the interest. So if the interest was missing, you'd just use that purple formula and you would hopefully know the interest rate. If you don't know the interest rate and they ask you what is it from an amortization table, that's how you can work it out. Okay, so if we look at some of the other things, it says like the principal reduction equals the payment made minus the interest earned. So if you look here, this number was equal that minus that equals that, yeah? So that's how we can work out principal reduction. And the balance of the loan, sorry, I'll just get another colour. All right, and the balance of the loan here is the previous balance minus the reduction. So I might use another one. So this balance equals the balance before minus that equals that one. All right, so that's what they're talking about. So this is an exam question. Now, just a few things to point out to you. I can see that this is question 23. The exam part section of this only goes to question 24. So 23 is saying to me this is one of the more difficult questions, yeah? So sometimes if you get to the end of the section and you think, oh, I did that so quick, just have a double check of yourself because it's probably a trap, yes? So you got to think this one is supposed to push the boundaries with your knowledge. All right, so that 29% is how many got it correct in the state when this was done for this exam question. So 29%. When you see that, you go, they're going to repeat this theory because only 29% of the state could get it right. They don't want that. That's not good enough. Yeah, so they'll push that. All right, for the next year. So 5 lines of the amortization table for a reducing balance loan. So you need to take note of that. So it's a reducing balance loan with monthly repayments as shown. So I've flicked back to a loan now. The interest rate for the loan changed immediately before the repayment number 28. The change in interest rate is best described. So can you see it changed here? The interest changed. So that amount of interest was something different to before. This is where we saw an interest rate change. But they want to know what the difference was. So we need to work out what the interest rate was at the beginning. So I might work that out first. So if we do like what we said before, we said interest equaled R over PPY over 100 times the balance before. Okay, so I'm going to use this interest, which is 967.08 equals the rate is what I want to know over PPY. Now they said here that it's monthly. So I put over 12 over 100 times the balance before, which is here, 0.78. So I'm going to use solve, and go comma R and work out this first, the blue interest rate. So I'll do that on the... So I got this one to be 5.04%, okay? But now they told me it changed down with the green here. So I'm going to do the same and work out the interest rate when it changed. So they said right before payment 28. So I know 28 has the new interest change. So once again, I'll use this formula and I'm going to use the new numbers. So I'll 1,002.26 equals R over 12 over 100. Do you think it went up or down? Why do you think it went up? Yeah, good. So it's good to think of those things because you might see if you made a mistake. So we said because the interest went up in value, so you would hope his loan's going down so that he was not paying as much interest. But because it went up, yeah, his interest is paying a bit more again. So that's what's happening. So good to think of those things so that you know if you accidentally stuff it up in the calculator, you type something wrong. If you see a rate that's smaller, you're like, well, wait a minute, I didn't think that would happen. Okay, so we get 5.28%. Now we have to be really careful here. They actually said what is this change in interest is best described as. Can you see whether they're saying how much it went up or down by? Now you already told me you thought it increased, didn't it? So get rid of decrease so you don't accidentally do that wrong. Now what would the difference be? It would be this 5.28 minus the blue one, 5.04. So it's gone up by 24. So A. So just to quickly go through Finance Solver with annuities. So we have Walker invests 200,000. So that is your PV, and because he's investing, it's a negative PV because it's an annuity. Okay, he said paying 5% compound interest per annum. So because they said 5%, that's the I per annum, and it's compounding monthly. So it's telling me PPY equals 12. He wishes to be paid monthly payments for 10 years. So 10 years would mean 10 times 12. And you can see that. So here I've put 10 times 12 and I've got that. Here's the 5, the negative 200,000. And so if he's going to invest 200,000, he's going to get 5% per annum, and he's going to take monthly interest and take monthly payments. That means every month he can get $2,121. All right, so can you see that? And then it says if he receives regular payments of 3,000, so the payments are negative. The payments are positive. So you're going to make it a positive 3,000 in payment, and it wants to know how long will the annuity last. That's like saying ends the question. So you can see we changed that, and then we put the question on the end, and we see that it says 78.2, and that's going to be months. So really you're going to change it. It's probably be, you'll say 78 months, because he really doesn't get the next month. He might just get a bonus bit extra on the last one. So if he goes to 78 months, you might look at that and say 6 years. No, what is it? Yeah, 6 years and a bit, 6.5 years. So, and what interest rate, correct to one decimal place, would allow Joe to withdraw 2,500? So that's a payment. So positive payment of 2,500 for 10 years. So 10's back to 10 times 12. And you want the interest rate to find. So there's that question. So we like changing it around there. Let's do this exam question here. The value of the annuity after n monthly, after n monthly payments of 55 can be determined using this recurrence relation. The value of the annuity after 5 payments made is closest to. So you could do it recursively on your calculator, or you could do it in Finance Solver, whichever one you want to do. This is question 18. It's not a very hard one. So let's go do it and see. You tell me which one the answer is. I'll check it for you. Okay, I did on the calculator. Did you guys get this? I got C. Good.